And our next speaker is going to be Petteri Kivimäki, who is joining us from Helsinki. He works for the Nordic Institute for Interoperability Solutions, which is an institute that works with different countries like Estonia, Finland, Iceland to collaborate on an open source software called XRoad. And Petteri is going to tell us more about the evaluating the environmental footprint of the open source software called XRoad. Hello, Petteri.
Hello, and thank you. It's really nice to be here. Thank you for the opportunity to give this presentation today about XRoad. So my name is Petteri Kivimäki. I'm the CTO of Nordic Institute for Interoperability Solutions, and my topic today is evaluating the environmental footprint of XRoad. And I have to say immediately that my approach to the topic, it's very practical, even though, of course, there is lots of theory behind this, but yeah, my topic is quite practical. And let's start with a little bit of background, since everyone probably isn't familiar with NIIS and XRoad. So NIIS is a non-profit association which mission is to develop digital government solutions to its members, and XRoad is the main product of NIIS. NIIS was established in 2017, and currently Estonia, Finland, and Iceland are members of NIIS. Instead, XRoad is an open source software and ecosystem solution that provides unified and secure data exchange between organizations. XRoad is used as a national data exchange solution in the NIIS member countries. But in addition to that, XRoad is used at least in 20 countries all around the world. For example, there is a big user community in Latin America. NIIS is responsible for the strategic management and development of XRoad, and NIIS has set a long-term goal to make XRoad the most sustainable data exchange solution in the world. But before getting there, of course, the first step is to understand where are we today, and therefore we have to understand and assess what are the factors that affect the environmental footprint, how to measure them, and also recognize potential improvements. To understand the current situation better, NIIS performed a study together with Go4 and the Stockholm Environment Institute. The study was conducted during the first half of 2021. The results of the study are publicly available on the NIIS website, and you can see the link here on the slide. The study was divided in 3 phases. First, define an emissions boundary and map the main causes of XRoad's environmental impact. Then second, build an XRoad carbon footprint calculator. And third, define recommendations for improving the sustainability of XRoad. The key function of XRoad is to provide secure data exchange between XRoad member organizations. XRoad is based on a so-called 4-corner model, just like e-delivery, which means that data is exchanged through unified access points. In e-delivery, they're called access points, and in XRoad, they're called security servers. So basically, XRoad is a secure peer-to-peer network over the public internet. And this diagram illustrates how XRoad works. And of course, in real life, XRoad is an ecosystem of multiple organizations. In Estonia and in Finland, we are talking about hundreds of organizations, hundreds of security servers. For simplification, this diagram only includes 2 member organizations. And the main idea of XRoad is that when data is exchanged over XRoad, every member organization has its own access point, security server, and the information systems are not connected with each other directly, but instead they communicate through the XRoad security servers. And the idea there is that the security server, it implements technical specification. And when all the communication flows through the security servers, it's guaranteed that all the communication, it implements certain policies and security features. And without the security server, every member organization would have to implement these measures directly to their information systems. And with XRoad, instead, all this comes out of the box. And even if you can see also other components here in this diagram, like the XRoad operator, the trust service providers, the main point is that data always flows directly between the service consumer and service provider. Also, the other components, they have an important role in establishing trust in the ecosystem, but when it comes to the actual data exchange, they do not play an active role in it. Data always flows directly between the service consumer and the service provider. And why I am emphasizing this is that this is an important fact when we were defining the scope for the environmental footprint evaluation. And since the security server is the key component which is required to exchange data, it was naturally recognized as the main source of emissions. And since the other components do not play an active role in the data exchange, they were not considered in this study. And also the life cycle assessment of hardware components was excluded. And within the security server, we identified 3 main sources of carbon emissions. So security server infrastructure, CPU and memory, then data transfer and data storage. So basically, if you think about almost any software solution, these are the resources that are required to run the software. But then, of course, the way how these resources are used by different software and also within the same software, it depends. For example, when it comes to XRoad, the security server, it's kind of a generic gateway to exchange data. So the workloads and the type of data, the amount of data, it can be very different in different cases. So that's why we need to do some further estimations to be able to understand how we can really calculate the environmental footprint in different kind of use cases. And to be able to do that, we needed to develop a model. And the model was developed using existing research data, best practices, and operational data collected from Estonian and Finnish ecosystems. So real data from real use cases. And first, a model for a single security server was developed, and then the results were multiplied with the total number of security servers in an entire XRoad ecosystem. So we wanted to be able to calculate the environmental footprint of a single security server, or let's say 5 of them, from an XRoad member organization's perspective, so that the member organization can calculate what is their environmental footprint. But then at the same time, it was very important that we are able to calculate the environmental footprint of a whole XRoad ecosystem. So for example, the XRoad ecosystem in Estonia or in Finland, so that the XRoad operator and the XRoad members, they both can use the calculator to do this kind of evaluations. Then another factor to consider is the energy consumption of the supporting infrastructure, for example, cooling, lighting, and so on. And the factor is known as the power use effectiveness, PUE. In this project, the value of 1.58 was used, which is an average for an on-premise data centers. And the smaller the value, the better it is. Some big cloud providers have values close to 1, and having the value as 1 would mean that the data center is completely carbon neutral. So that is obviously the goal there. And the final step is to convert the results into an estimation of released emissions by multiplying them by an emission factor for grid electricity. The emission factor tells how clean the grid electricity is, and it varies between different countries. So overall, the total emissions are caused by the security server infrastructure, data transfer and data storage that are affected by the power use effectiveness and emission factor. And in practice, it means that running exactly the same workload on the same infrastructure in 2 different countries leads to different amount of emissions. So on the right corner here, you can see some examples of electric emission factors of different countries. So, for example, if you compare Iceland and Estonia, the difference is pretty big. And yeah, if you run the security server with the same hardware setup and the same workload in Estonia and in Iceland, the carbon footprint it's completely different. That's actually very interesting information. Not just between Iceland and Estonia, of course, but in general, I mean. And based on the model, we developed an Excel-based calculator, and this is it. And even if operational data from Estonia and Finland was used in the development, the calculator can be used to calculate XRoad's environmental footprint anywhere in the world. So there's nothing Estonia and Finland specific about it. The calculator is available for a single security server and for an entire XRoad ecosystem. And first, the user must provide some input data, like number of security servers, average CPU utilization, amount of data exchange, amount of data stored, and so on. And then, of course, this calculator, it contains lots of other parameters as well. But we provide, or the calculator provides, default values for them. And if the user has more detailed information regarding some of those values, of course they can be changed and updated. For example, the power use effectiveness, PUE, is one of the input values, and the default is 1.58. But that's the default for on-premise data centers. But for example, the big public cloud providers, they provide their PUE values publicly on their website. So instead, if you are running your security server on Google, Microsoft, or Amazon clouds, then you could change the value in the calculator based on the information they provide. And of course, it means that the result is more accurate for your use case. And then the calculator shows the results, as you can see on the right. First, we have the summary of results. So we have the different elements of the security server. So infrastructure, data transaction, and data storage. What's their portion of the total emissions? And the number of the amount of carbon emissions that the calculator shows, at least for me personally, only the number, it doesn't say that much. And probably I assume that it's like that for most of the people. And therefore, we also provide a comparison on the bottom right corner, how many round-trip flights from Tallinn to Lisbon would be required to produce the same amount of emissions. So that's kind of a good way to understand the scale of the emissions that we are talking about. And then we use the calculator to calculate the emissions of the Estonian and Finnish XRoad ecosystems. The difference between the two countries relates mostly to the difference in average electricity grid emission factor. As we saw a couple of slides ago, the emission grid factor for Estonia was pretty high. I think it was something like a double compared to Finland. So that's one important reason behind the difference. And it's also very interesting to see that around 96% of total emissions are related to the operations of the security servers. So we are talking about the CPU and memory. And data transfer and storage share only 4% of the total emissions. And one reason or explanation for this probably is that XRoad it's used for data exchange, and in this case, data exchange means mostly synchronous messages, usually pretty small messages. For example, fetching personal data from the population registry or different information systems. XRoad is not a streaming platform. You cannot use it for streaming videos, for example. So that's probably one reason why the data transfer, the share of data transfer isn't bigger than that. For example, when we talk about online video streaming services like Netflix, then these numbers probably would look quite different. And here we have a list of recommendations for improvements. Even if these were created in an XRoad specific project, many of these can be applied to any software product. For example, flexibility to disable functionalities that are not needed, use of power-efficient devices, use renewable electricity, and so on. Those are quite generic and can be applied to any software. And the next step is to start implementing the recommendations that we recognized in the study. And actually, we've already implemented some of them, and they were included in the latest XRoad release that was published in November. But that's only the first step, and the work will continue in the future. We aim to assess the environmental footprint of XRoad development process as well, since this study concentrated on the software only. And it's also worth mentioning that this study concentrated only on the negative impacts to the environment. It didn't take into account potential emission reductions elsewhere. And what I mean by this is that XRoad is an enabler for digitalization, and it helps to digitalize and streamline processes and services that should have a positive impact on the environmental footprint elsewhere. So even if deploying XRoad brings new emissions, the overall aim is to decrease the environmental impact in the big picture. And hopefully in the future, we are able to conduct another study that would take the big picture into account and measure the overall impact of XRoad. But I know that it's a lot more complicated task than this. Thank you for listening. Now it's time for questions.
Thank you, Petteri. Yeah, a few questions. Don't hesitate to ask your question if you want in the chat. My first question would be, what led you actually to evaluate the environmental footprint of XRoad?
Yeah, that's a good question. So obviously, environmental related topics, they are very, very important these days. They concern all of us. And we know that lots of work regarding environment and environmental footprint has already been done regarding data centers, hardware, and so on. But at least when we started to look into this project I think it was during the second half of 2020, there wasn't too much information available about environmental footprint of software products. So we thought that it would be really regarding the environmental footprint of XRoad as a software product, since it is an area that hasn't been studied so much yet. So yeah, that's how we got started, and of course, like I said in the beginning, we aim to make XRoad the most environmentally friendly data exchange layer in the world. So this was the first step to understand where are we now, recognize improvements, and now start to work on the improvements.
Sounds great. And at the end, you were talking about the next steps. And do you have any concrete examples of the changes you will implement for XRoad based on the recommendation of the study? Did you hear me?
Sorry, no, there was some problem with the connection. Could you repeat the question, please?
Okay, I'll just ask you again. You were talking about the next steps at the end of your presentation, and I was wondering if you could give us concrete examples of what you're going to do on your roadmap to improve XRoad, basically.
Yeah, so like I said, we have already started to implement some changes on XRoad, and what we've done so far is that we have made XRoad more modular. So before, when you installed XRoad, you got a bunch of features every time when you installed it, whether you use them or not. And now we have made XRoad more modular, which means that when you do the installation, you actually have more choices. You can choose what features you need, and then if you don't need something, you can skip those. And of course, it makes the security server more lightweight to run, and it means that it consumes less electricity. So this is something that we have already done.
Oh, that sounds great. Yeah, indeed, if you can reduce the amount of data that can transmit through the system is great. Well, thank you so much, Petteri. Thank you for your presentation.
Thank you.